Welcome to the Nutrient Sources and Purpose section of Introduction to Commercial Animal Feed Labels. I'm Jim Hillary, the Agriculture and Natural Resources Extension Agent for Virginia Cooperative Extension in Loudoun County, Virginia. This presentation supports the 8008 series curriculum, Introduction to Animal Systems, developed by Virginia's Office of Career, Technical, and Adult Education Services. The objectives of this class are to identify and describe sources of nutrients used in commercial animal feeds and outline the functions or purposes of nutrients used in commercial animal feeds. So, what are nutrients? Nutrients are substances necessary for animals to live and grow. Normally, nutrients are provided to animals through their food. They make it possible for cells to live, grow, and function properly. Many nutrients are needed, and they must be in the proper balance. When one or more nutrients are missing or deficient, an animal can die, become sick, or simply not thrive. Types or groups of nutrients. People often agree to disagree about the number of nutrient groups. In this class, we will introduce 6 types: water, protein, carbohydrates, fats and oils, minerals, and vitamins. It might be helpful to use this memory tool made from the first letter of the name of each nutrient group: W, P, C, F, M, and V. So, what powers cars fuels many vehicles. As a nutrient, water makes up most of the living organism, in fact, 40 to 80%. Water helps regulate body functions. It helps promote biochemical processes. Water helps dissolve nutrients and control an animal's body temperature. And water in the blood acts as a carrier of other nutrients and is necessary for chemical reactions. Did you know that an animal can live longer without any food than it can without any water? Proteins are needed by animals for growing new tissue and repairing old tissue. The highest amount of protein is found in an animal's muscles. Proteins consist of amino acids, the building blocks of proteins. There are 23 amino acids. 10 are essential, which means they must come from food, for they cannot be made by the animal's body. As stated in the previous slide, proteins are made of amino acids. Amino acids in turn contain carbon, hydrogen, oxygen, and nitrogen. Some amino acids may contain sulfur, phosphorus, and iron. There are 2 types of protein sources that we will discuss in this class. The first is animal source proteins, and the second is plant source proteins. Animal source protein is thought by some to be a higher quality protein because it contains a good balance of essential amino acids. Plant source protein is thought by some to be a lesser quality protein because it lacks some amino acids. We'll leave the discussion of animal source protein versus plant source protein for another class. Examples of plant and animal protein sources. Plant protein includes corn, soybean meal, cottonseed meal, and dehydrated alfalfa meal. Animal protein sources include meat meal, fish meal, dried milk, and bone meal. Carbohydrates. Because of the number of times that I will be saying the word carbohydrates, I'm going to shorten the word to something simpler and easier to say: carb. Carbs are an animal's energy source. Energy powers muscular movement. Carbs help produce body heat. Carbs are made up of sugars, starches, cellulose, and lignin. Carbs are composed of carbon, hydrogen, and oxygen. Extra carbs are stored as fat. Sources of carbs. In commercial animal feeds, the sources of carbs include cereal grains such as corn, wheat, barley, oats, and rye. Fats and oils. Fats and oils are made up of carbon, hydrogen, and oxygen, but contain more carbon and hydrogen atoms than carbs. For this reason, fats have 2¼ times the energy value than carbs. Fats are solid at body temperature. Oils are liquid at body temperature. Vitamins. Vitamins are nutrients found in trace organic compounds. They are only needed in small amounts. All vitamins contain carbon, and there are two categories of vitamins: fat-soluble and water-soluble. Fat-soluble vitamins include vitamins A, vitamin D, vitamin E, and vitamin K. Vitamin A is associated with healthy eyes, good conception rates, and disease resistance. Vitamin D is associated with good bone development and mineral balance of the blood. Vitamin E is associated with normal reproduction and muscle development, and vitamin K helps with blood clotting and prevents excessive bleeding from injuries. Sources of fat-soluble vitamins include green leafy hay, yellow corn, cod liver, fish oils, wheat oil, and vitamin D is produced in the body when sunlight is present. Water-soluble vitamins include vitamin B complex and vitamin C. Vitamin B complex is needed for chemical reactions in the body and to help improve appetite, growth, and reproduction. Vitamin C helps formation of bone and teeth and prevents infection. Sources of water-soluble vitamins. Vitamin B complex sources include green pastures, cereal grains, hay, milk, fish solubles, and animal proteins. Vitamin C is found in green pastures, and also farm animals can produce vitamin C in their body. Minerals. Minerals are nutrients needed in small amounts. They provide material for the growth of bones, teeth, and tissue. Minerals also regulate chemical processes, aid in muscular activities, and release energy for body heat. We will review two types of minerals in this class: major and trace minerals. Major minerals. Major minerals are needed in larger amounts than trace minerals. Some example major minerals include calcium for bones and teeth, blood clotting, and muscle movement. Magnesium, which helps turn food into energy. It is important for bones. Phosphorus is also needed for strong bones and teeth. It helps turn food into energy and to store extra energy for later use. Potassium for water balance, muscle movement, and nerve impulses. Potassium works with sodium to control blood pressure. And sodium for water balance and muscle movement. Sodium works with potassium to control blood pressure. Trace minerals. Trace minerals are needed in smaller amounts than major minerals. Some trace minerals are potassium, sulfur, magnesium, iron, iodine, copper, cobalt, zinc, manganese, boron, fluorine, and selenium. Trace minerals are often added to commercial feeds or made available through free choice mineral blocks. This is the last content slide in this portion of Introduction to Commercial Feed Labels. The references below were read or reviewed during the development of this program.